Okay, we're going to graph a function here with a host of transformations embedded in it. We're going to have reflections, stretches, vertical and horizontal, as well as phase shifts and vertical translations upwards. So our function is a sine function, and I'm going to just start off by putting the table of values there at the side. And I'm going to be using the mapping notation to sketch this. Once we're done, we're going to state some of the properties of this new graph. And keep in mind that the range in which we are actually graphing this is between 0 and 180. Okay, so we're not going all the way to 360 this time, which is fine. So mapping notation. Well, let me just move this out of the way. If you recall, we have x comma y gets mapped to, if I look at the transformations, it'll be 1 over b x minus the h value, comma, ay plus k. Now in this case, our a value is -2, so over here, I have my a value, my b value is 3, my h value is 30, and my k value is 2. So my mapping is going to be x comma y maps to 1 over 3x minus 30 minus 2y plus 2. And we're going to basically, let me just move this for a sec. We're going to put all these points, 1, 2, 3, 4, 5, into this equation here. Okay, and see where they get mapped to, one at a time. Just get this out of here. So let's start off with 0, 0. What happens to 0, 0? I'll do it over here. 0, comma 0, according to our mapping notation, gets, I'm going to put a 0 for x here and a 0 for y. We'll go to -30, comma 2. And then 90, comma 1 will go to, what do we have here? 0, comma 0. And then 180, comma 0 gets mapped to, that'll be 60, comma 2. And then we have 270, comma 0 gets mapped to, sorry, -1, my bad, 270, -1. 270 divided by 3, that'll be 90, minus that'll be 60. Sorry. Oops, I did forget something in the previous one. I did forget to subtract 30, so this will be 30, because 180 divided by 3 is 60, minus 30 is 30. This will be 60. And this will go to 4. And then we have 360, comma 0, which will go to 360 divided by 3 is, so this will be 90. I think at this point you can kind of see the pattern here, here, here. They're all going up by 30. And we're going to finish off at, what do we have here? 0 will get mapped to the value of 2. Okay, so here are our points, -30 and 2, 0, 0, 32, 64, 92. Let's graph these. We'll use slightly larger dot. So -30 and 2, which will be, so if let's see, 1, 2, 3, 4, 5, 6, if 6 blocks are 90, then 2 of those is 30. So So negative 30 will be over here, and 2. So there's our first point. Our second point is 0, 0. Then we have 32. And then we have 60 and 4, which is over here, 90 and 2. There we go. Get this out of the way. I'm going to now connect these lines nice and smoothly. So we start from here, go down, come up, and go down again. Now remember, we wanted to graph this between 0 and 180, but remember, if you have one cycle, you pretty much have as much as you want. So I'm just going to kind of take a shortcut with my notepad here. I'm going to paste another copy of this. I'm not going to use it all. I'm just going to paste it for now. And then with my eraser, let's use a little slightly larger one. Well, I'm going to delete everything. Oops. Let's actually use a white pencil. Everything before 0 and everything after 180. I'm including 180 and I'm including 0. So I should make that clear. So at 180 I'm going to be over here, and at 0 I will be over here. At what do I have there? 120 down here. I believe that's 150. I'll be over here. Then 180 I'll be over there. Okay, so you have your function graphed between an interval of 0 and 180. The amplitude, so let's kind of cut through the center here. The amplitude is the height from the middle to the top or the middle to the bottom. And you can see that the value of that is 2, so that's 2. The period, how much it takes to complete one cycle, well, it goes from 0, and then over here is 120. So from 0 to 120, that's the period. So 120 degrees is the period. 2 is the amp. By the way, you can always get the period by dividing 3 into 360. 360 divided by 3 is equal to 120. The sinusoidal, the range, my bad, let's focus on that. The range, well, it's everything from, basically, if I were to draw a line here, everything from 0 all the way up to 4. Okay, everything from 0 to 4. So our range is bounded by that. So let's write that off to the side. Just make some space here. Put this over here. So range is equal to all y values, all real numbers y, such that I'm going to have to move this over a bit. 0 is less than or equal to y, which is less than or equal to 4. The sinusoidal axis, that's this guy in the middle. It's going to be y equals 2. And the phase shift, well, if you recall, sine starts, let me just put it backward, kind of over here, and then it moves over. Okay, so in this case, you can see, I mean, pretty much from the equation, this plus 30 means it's going to move to, where does it go? It'll move over to the right 30 degrees. Sorry, to the left 30 degrees. Remember, this is also being reflected, so I'm not kind of taking that into consideration, but 30 degrees means it's being moved left 30 degrees. So phase shift is left 30 degrees. And again, that's not so clear here, but because there is that, you know, reflection, so kind of puts everything, you know, it's not crystal clear, but we do know that if it's a plus 30, we are moving left. Okay, so there is graphing a function, a sinusoidal function with a whole bunch of properties in it, and you should practice some more.